Yes. Hello everyone, welcome to MK Academic Solutions. So in this video I am going to explain you about the Le Chatelier principles applications. We know what is the Le Chatelier principle, right? So Le Chatelier principle says that when you change the concentration or temperature or pressure at equilibrium, the equilibrium is going to shift in the direction in which the net effect is going to be nullified or neutralized. Okay, and now in this video I am going to explain about the Le Chatelier applications of Le Chatelier principle. So this is actually used in the industrial scale. So the first preparation of ammonia by Haber's process. Okay, we know what is the Haber's process here. Preparation of ammonia by Haber's process. So here N2 gas plus 3H2 gas is gives rise to 2NH3 gas and it giving 92 kilojoules of energy. So now it is an exothermic reaction. So it is exothermic reaction. Exothermic reaction. So we know already according to Le Chatelier principle, in exothermic reaction low temperature is favorable. Exothermic reaction, low temperature is favorable. Low temperature is favorable means at low temperature more forward reaction is going to be take place. But at low temperature the rate of reaction is very slow. So to increase the rate of reaction they are using the optimum temperature, that is 725 to 775 Kelvin. So actually your low temperature more forward, but at low temperature rate of reaction is slow. Rate of reaction is slow. That's why what they use optimum temperature is used. What is the optimum temperature? Here optimum temperature means neither low or not too high. Optimum temperature used, that is 725 Kelvin to 775 Kelvin. 725 to 775 Kelvin they used. And next here effect of pressure. So what is the effect of pressure? We know pressure increases, the equilibrium shift towards the less number of moles. Why? Because if pressure increases, volume is going to decrease. So if volume decreases, what will happen? The equilibrium shift towards the more number of moles or less number of moles. So here product is having what? Less number of moles. So that's why here we are going to use high pressure. So high pressure increases, low number of moles. So where we are having the low number of moles? At the product side. We want ammonia only. Preparation of ammonia means what is the desired product here? Ammonia only. So that what we are going to do? We are going to use very high pressure. At high pressure the equilibrium shift in the forward direction. So more amount of ammonia is going to produce. So here high pressure. So here 200 atmospheric pressure they are going to use to prepare the ammonia. And next catalyst. Next here catalyst. See, catalyst. So here which is the catalyst they are going to use? Iron catalyst they are going to use, and iron is the catalyst. So why they used the catalyst? So we already know catalyst does not have any effect on the state of equilibrium. But what a catalyst can do? Catalyst can speed up the attainment of equilibrium. So to speed up the attainment of equilibrium only they are going to use the iron catalyst, and here they use molybdenum as a promoter, as a promoter. So we know promoter, what the promoter will do, children? Promoter increases the efficiency of catalyst. It increases efficiency of catalyst, increases efficiency of catalyst. It increases the efficiency of catalyst. Okay, so this is about the industrial synthesis of ammonia or preparation of synthesis of ammonia by Haber's process. So here it is exothermic reaction. So here heat energy is going to be released. So that's why we are telling it is an exothermic reaction. Okay. Next, means what are the conditions here favorable? Low temperature is not favorable, high temperature also not favorable, optimum temperature region also is there, and pressure is must be very high. Why? Because at product is having less number of moles. So we want product only. So at high pressure only the equilibrium is going to shift towards the product side. And catalyst cannot affect on the state of equilibrium, but it speed ups the attainment of equilibrium. Okay. Next, let us see industrial synthesis of sulfur trioxide, SO3 gas. Okay, this preparation is also known as what? Contact process. So in preparation of SO3, so 2 moles of SO2 and 1 mole of what is gives rise to 2 moles of SO3, and here heat energy is going to be released. Here also like preparation of ammonia, here heat energy releases means it is also what? Exothermic reaction. Exothermic reactions, we know low temperature is favorable. Low temperature is favorable, but at very low temperature here also the rate of reaction is slow. At low temperature rate of reaction is slow. That's why what they use the optimum temperature at. So here also which temperature used? Optimum temperature up 625 Kelvin, up to 625 to 650 Kelvin they use. And next, when you see the effect of pressure, so when you see the effect of pressure, here we know pressure increases, the equilibrium shift towards the less number of moles. So here when you see the delta N or number of moles at the reactants 3 and number of moles at the products is 2, which means here delta N is less than 0. When delta N is less than 0, so the product, if pressure increases, the equilibrium shift towards the product side. So here we want product only. So here high pressure is favorable. High pressure is favorable, actually favorable for more SO3, but here we have a difficulty with the high pressure. So when we are going to use high pressure, what will happen? The towers or the instruments which are used to prepare this sulfur trioxide gas are going to corrode. So here they use towers. They use the huge towers to prepare SO3 gas. So here SO3 and SO2 both are having what? Acidic character. They are having what? Acidic character. Due to acidic character, what is happening here? The towers which we are going to use here are going to get corrode. So that's why they are not at all going to use very high pressure, and optimum pressure is used. So acidic character and these towers are going to corrode at high pressure, at high pressure. So this is the difficulty in the using of high pressure here. That's why they use what? Optimum pressure, optimum pressure, optimum pressure they use to prepare the sulfur trioxide gas. Okay. Next we'll see synthesis of nitric oxide. This is also known as Birkeland ID process. See here, N2 gas plus O2 gas is gives rise to 2NO gas, and here delta H is positive. Here delta H is positive. Delta H is positive means it is endothermic reaction. So here it is the endothermic reaction, endothermic reaction. So some people may get out, sir, in previous also you are having plus sign only. Likewise, see here we are having plus sign, but it is along with the product. If along with the product made, here this much energy is released, and here directly they have given delta H. Delta H is equal to positive means here this much heat energy is absorbed by the system. Means heat energy absorbed by the system means that is endothermic reaction only. So here it is endothermic reaction means low temperature is favorable or high temperature is favorable. So endothermic means high temperature. High temperature is favorable, and second condition here we can give. See here pressure. What is the pressure effect here? See here delta N is equal to 0. Delta N equal to 0. 2 minus 2, that is equal to 0. Means here pressure has no effect. Pressure has no effect. Pressure has no effect. Pressure has no effect on the state of equilibrium. And next, so here concentration. So you want more amount of NO gas means we should take the more N2 and O2. More N2 comma O2 is favorable for the more product. So increasing the concentration of reactants is more favorable, and or decreasing the concentration of product is also more favorable condition. Okay. So this is about the synthesis of nitric oxide by Birkeland ID process. Next, oxidation of CO by the steam, Bose process. Okay, this process is called Bose process. Oxidation of CO. CO gases react with water. So in presence of water in the state of steam, and it produces CO2 gas and H2 gas, and here X kilocalories means this much of heat energy released here, heat released here, plus delta X means when you write with delta H, when you write with the delta H, that is equal to minus X kilojoules. Means here delta H is negative means that is exothermic reaction. So it is the exothermic. Exothermic means which temperature is favorable? Low temperature. Low temperature is favorable for the forward reaction. And here pressure. Pressure, see children, here CO is in the gaseous state, H2O also in the gaseous state. CO is in gaseous state and H2 is on the gaseous state. Okay. So now here delta N is equal to 0. Here what? Delta N equal to 0. Here 1 plus 1 2, and here also 1 plus 1 2, and you just see the whether it is balanced or not. 1 carbon, and oxygens 1 2 oxygens, 2 hydrogens, 2 hydrogens. Okay, balanced only. So delta N is equal to 0. If delta N is equal to 0, we already know no effect of pressure. No effect of pressure. Pressure has no effect on the state of equilibrium. And you take, so now still what are the conditions we can apply here to get the more amount of product? Means you can increase the concentration of reactants, or what are the reactants? CO and H2O. More CO and H2O, steam we can use. So these are the conditions for what, children? Oxidation of CO by steam or Bose process. So exothermic means low temperature use and pressure has no effect, more amount of CO and H2O, and even you can use catalyst also, no problem. But these are the catalyst. What the catalyst hardly can do, it speed up the attainment of equilibrium. Okay, right. Next, melting of ice. So what is the melting of ice? Means solid ice converted into water. This process is known as what? Melting of ice. So here ice is having low volume, water is having high volume. We already know, no, it's wrong, so opposite totally. So ice is having high volume, water is having what? Low volume. Okay, and here this process, forward process is what? Exothermic or endothermic means it is endothermic. Forward is endothermic process. Okay, it is the endothermic. Endothermic means when you supply the heat energy only, ice is going to convert it into water, isn't it or not? That's why heat energy is absorbed in the forward process. That's why it is an endothermic process. Okay, so forward is endothermic process. Okay, now let us apply the conditions here. So first, low temperature or high temperature means the first one is we can take high temperature. Next, coming to pressure. Pressure must be low or high. See here, water is having what? Low value. Ice is having high value. So when you increase the pressure, the volume is going to decrease. So low value which is having in that side only, equilibrium is going to be shift. Okay, so here low value means the pressure is what? High pressure is the favorable condition for to convert ice into water. Okay, right. So this is the melting of ice condition. And next, coming to the boiling of water. So boiling of water means water in the liquid state, and water in gaseous state. Water in the liquid state and water in the gaseous state. So here water in the liquid state have low volume, and water in the gaseous state is having high volume, same amount only. And here forward is again, this forward is endothermic. So here, what about the temperature for endothermic reactions? We know already. For endothermic reactions, high temperature is required. Means when you supply the more amount of heat only, the water is going to be converted as gaseous state or water vapor. Means liquid water is converted into gaseous state. So temperature should be high. High temperature, or simply high temperature. Temperature is more. High temperature is favorable for the endothermic process. And what about pressure condition? See here, more pressure means it should occupy less volume. Pressure is inversely proportional to pressure is inversely proportional to volume. See here, gas is having what, children? Gas is having high volume, means water vapor is having high volume. So if you want more volume means pressure should be decreased, means low pressure. So here low pressure condition is favorable. Low pressure condition is what? Favorable for the formation of water in the gaseous state. For the formation of water in the gaseous state means for the forward reaction. So these are the applications of Le Chatelier principle in case of melting of ice and boiling of water. And next you see effect of temperature on solubility of substances. So here we know already generally what happens children, generally temperature increases, solubility of solid is also increases. Temperature increases, solubility of solids also increases. See for example sugar, when you add sugar in the water at low temperature very few amount of sugar is going to dissolve, and when you increase the temperature more amount of sugar is also going to be dissolved. Okay, and for example you take sugar and also NaI, sod, not NaI, sugar and salts like copper sulfate, okay, and iron sulfate etc., copper sulfate and calcium, KNO3 potassium nitrate and KCl potassium chloride etc., all these are going to dissolve, these are going to dissolve on increasing temperature. So here temperature is directly proportional to what? Solubility means here if forward reaction is what? Endothermic process. So high temperature is favorable for the solubility of this type of solids. But when you take some examples, like examples like sodium iodide and cerium sulfate, CeSO4, cerium sulfate 9H2O, and when you take some more examples like lithium carbonate Li2CO3, lithium carbonate Li2CO3 and lithium sulfate Li2SO4 etc., what they are going to do, on increasing the temperature their solubility is going to decrease, means here solubility is exothermic process. So in case of exothermic process the solubility decreases on increasing the temperature. So here temperature is inversely proportional to solubility. Temperature is inversely proportional to what? Solubility. Okay, this is also some of the applications like Le Chatelier principle. And next, solubility of gas. So solubility of gas. Solubility of gas. Okay, solubility of gas. Okay, solubility of gas. So you know here solubility of gas is inversely proportional. Solubility of temperature is inversely proportional to solubility of gas. Okay, so solubility of gas means temperature increases, what will happen? Temperature increases, solubility of gas is going to be decrease. Okay, so here when you observe solubility versus temperature, solubility of gas versus temperature. So here temperature increases, solubility of gas is going to decrease. That's why to dissolve the gases, in any solution, what they will do, low temperature condition they use and high pressure condition they use. So when you use high pressure condition also the gases are going to be soluble. So these are also applications. So pressure is directly proportional to solubility, and so means at high pressure more solubility of gas, and at low temperature more solubility of gas. So these are the conditions they are going to utilize in the dissolving of gases in the liquids. So if for example in the carbonated water, so they are going to dissolve the carbon dioxide in the water. So how they are going to dissolve the more carbon dioxide in the water means by using these conditions only. So what are the conditions? Low temperature condition and high pressure conditions. So and also in the preparation of soda water also they are going to use. These are the conditions. Okay. So these are also what applications of Le Chatelier principle. Okay. So with this I am going to end this video, and this is the last video in the chemical equilibrium chapter. Okay. So the total chapter I have explained to you, and you can revise the concepts and you can read that concepts, and if you want anybody of write notes of this chemical equilibrium, you please text me and I will send the notes. Okay. Thank you for watching.